Okay, welcome to the webinar. We'll get started here. My name is Jim Brunig, and today I'm going to be presenting to you the webinar on the TI 191 inspection and how to prepare for it and what to expect when the NRC comes to your site. Just a few housekeeping things before we get started here. This presentation is about 45 minutes long. 45 minutes to an hour long. We'll go through this whole presentation. If you're interested in anything, you can feel free to contact me afterwards. My email is there. I'll also be sending out the presentation and posting it to the website so that you can share it with others. And we'll be recording this broadcast too and share the broadcast as well. Without further ado, we can get started here. Let's see. Okay. So the topics we're going to cover, as I mentioned before, when I spoke to most of you, I'm going to talk a little bit about our company, Exceed, and then we're going to move into industry flex inspection status, give an idea of where the industry is at right now, who's gone, who hasn't, and what the plans are. Then we're going to cover the NRC findings and observations, and then regional trends. Best practices was added to this presentation. Because we went to the conference last week, and there were some sites that shared some very good best practices. So we're going to include those here in this presentation. Then we're going to cover our method that we use when we do audits for sites before their inspection. We call it the compliance matrix process, and we'll cover more detail on that later. And the next is open discussion. Okay. So first about us, we are a professional engineering firm specializing in mechanical and civil engineering, and we also do regulatory consulting. We've been working on the Fukushima project since 2012 when the orders first came out as project engineers. We worked at Gannett for several years designing the strategies there, and we've since left and we've helped other sites with design of strategies, design of protective features, and things of that nature. So here's some of the projects that we did there. Like I said, tornado missile barriers, we've done the RCP-CO leak-off evaluations, modification constructability reviews, inspection preparations, and we also do design verification services. So moving on, what to expect when the NRC inspects your site. So their goal, in terms of timeline, they're going to within 6 months of your compliance date, you should be getting your SE, your safety evaluation. And then within 6 months of the safety evaluation, you should be getting your inspection. This year, there's going to be a big bow wave of inspections. So I would be expecting that schedule to slip. I think it's already slipped for some people. But that is a goal. And that's what was presented by the NRC last week. When they come to your site, there's going to be about 4 to 6 inspectors. And according to the TI, they have a man-hour estimate of about 100 man-hours per site reviewing your strategy for this overall inspection process. When they get to your site, first they're going to do a tabletop review. First, there's actually it's best to give them a presentation on your strategy. But overall, after the presentation, the NRC is going to want to see a tabletop review and see exactly how the strategy works. And with respect to time and resources. Then they're going to do field walkdowns. Speaking to the NRC, most of the issues that they have found that were really of any significance were in the field. There's a lot of documentation errors that were found, but most of the issues of any significance were found in the field, according to the NRC. And the normal exit is on Thursday. It could be pushed to Friday, depending on your site and how quickly you can respond to the NRC and your schedule, but the plan is to exit on Thursday, and the NRC also said that they try and treat Sunday as the travel day, so you can expect Monday through Thursday, with Monday, Tuesday, and Wednesday being high focus days on answering questions, and then Thursday is an exit. So the industry status, where are we now? First, I guess, are there any questions on what to expect when the NRC comes to your site? None. Next is industry status. So where are we now? So over 25% of the inspections have already been completed. I think it's about 17 sites as of tomorrow. This week, I think we had Sequoia and Grand Gulf. I think those are the only two going this week. But that's about where we are. 50% of the SEs are issued. They've found no significant issues. There were green findings, but no issues of significance that basically invalidated people's strategies. The bulk of the inspections is, like I said, is going to happen in 2017, and then there's going to be a few remaining in 2018. I expect there's going to be more than what they proposed in 2018, but I guess we'll see how quickly they can get through the bow wave in 2017 of the inspections. So this chart was presented at the conference last week. This shows the number of inspections for each region that have already been completed. You can see Region 2 and 3 are leading the pack with 5 inspections. And there's actually been 2 more inspections, one at Grand Gulf and one at Sequoia. So a few more to add to this list here. Okay. So upcoming inspections. So as I said, 2017 is a bow wave of inspections. Most of them are 2017. There's also a lot in 2018, and then 2019 it peters off in 2019. Go back. So findings and observations. I should say back here at the 2019 sites are going to be few and far between. There's a couple BWRs that said that their flex strategy and their hardened vents inspection, or that overall process, they wanted to marry it together a little bit more. And hardened vents is a longer schedule, so they asked the NRC if they could push out the flex inspection until hardened vents were complete, and they got approval for that. So that's why a few sites pushed out to 2019. It's because of the hardened vents. Next is findings and observations. So the first finding we're going to talk about was at Clinton. Clinton got a green finding because of hose issues. They had a 12-inch diameter lay flat hose that had 2 issues. The first one was routing it around structures and equipment caused the hose to have a very tight bend radius, and it was tighter than what the manufacturer recommended. And the NRC questioned whether or not that hose would be capable of performing on that tight bend radius, whether or not it would cause a significant drop in flow, or if it would cause a rupture. So they didn't have documentation for that. They didn't have an analysis or documentation that they could operate outside of vendor recommended areas. So they had to they basically did a test to show that the hose would be capable of performing its function. The other issue was related to coupling stress. They had the 12-inch lay flat hose, the same hose actually went up a 28-foot drop, went down, I guess, a 28-foot drop, and the weight of that hose on the couplings was not analyzed. It wasn't. It was outside what the vendor had expected or what the vendor had specified, and they didn't have an analysis saying that was going to be acceptable. So they ended up doing a finite element analysis and showing that it would work. But again, so the overall issue at Clinton was that they just didn't have the calculations and analyses to prove that they would be capable of mitigating the event. The next issue was at Perry. So Perry got 2 findings. They had both green. And the first one was because Perry did not have a program in place for periodic replacement of hoses. The lay flat hoses generally have a shelf life, and they have to be replaced periodically. Perry didn't have a PM program in place to do that. The other issue was the PMs to check operation of communications equipment. They didn't have anything in place that wasn't acceptable to the NRC. It was, and this is we've seen as a potential vulnerability at some other places we've been. A lot of times people focus on flex and the flex PMs and optimizing all the flex PMs, and they forget about communications. And you need to make sure that there are communication PMs that will check and make sure your equipment works. could be as simple as making a phone call and just making sure that that equipment will work in the event of a disaster. So these are the issues that were presented by the NRC, other issues we'll call them. So the lack of PMs on flex pumps, communications equipment, and the hose replacement program. So we talked about some of those already. And infield issues, so the hose bend radius issue that we talked about. Another one was adapter clearances. This one was an interesting one. The NRC brought this up that a site had installed these adapters for steam generator makeup on a Unit 1 and Unit 2, and they were pretty similar on Unit 1 and Unit 2, except Unit 2 had some interferences right near the adapter, and on Unit 1 it didn't have those interferences. So, and it happened to be when they did their validation and they went out and checked everything and timed everything, they only did one unit. They didn't do the opposite unit. So the NRC happened to walk down the unit that was not validated, and they noticed that there were some clearance issues for the steam generator makeup adapter. This didn't result in a finding, but it could have. This could have been significant. So the takeaway I see from that is if you had 2 units and you did a validation on 1 unit, you should definitely walk down your other unit and make sure that you can do your connections. Make sure that you can still do your connections with a reasonable amount of time compared to Unit 1 or your opposite unit that you did. It's very important. The other one was the tripping of the Phase 1 pumps. This was related to jumpers, basically. So the site had, to get the Phase 2 equipment running, or it may have even been Phase 3 equipment, they would install jumpers in some electrical cabinets, and by installing those jumpers, it would cause the Phase 1 pumps to trip. So you just, that's a design issue. It's a flex design issue, but it's a lesson learned to make sure things like that wouldn't happen to you. Next one's FSG quality. This is actually, I see this as a potentially bigger issue than it appears to be. These are typos, inconsistent label references, links to deleted steps. The problem with quality, if you have minor issues in your FSGs, it raises a red flag in the inspector's mind. As you all probably know and understand, that if you find a quality issue and you find a procedure with a couple typos in it, how much review did that procedure really get? And if it didn't get a really good review, then if I'm inspecting your site, I'm going to dig in a little harder and take a really close look at that procedure because something may have gotten missed. So that's important to make sure your FSG quality, even the small issues, are buttoned up. The next was 5054X references. This was a question the whole industry had years ago on how many statements can you put about 5054X in your procedures. So 5054X, for those not familiar, basically it allows the operator to make decisions based on what needs to get done, and it's their judgment. They can operate outside a procedure to mitigate the event. But you can't proceduralize this. I'll write this down. 5054X. You can't proceduralize somebody to go outside a procedure. It's kind of a catch-22. You can't get there. If you proceduralize, your procedures have to be safe, but then 5054X will kick you out. So what I'm trying to say is 5054X references in procedures have to be very carefully controlled. You can't have a procedure step that says the next step requires implementation of 5054X, or you can't have a procedure that says implement 5054X, because you're basically saying go outside a procedure to stay in my procedure. And you can't do that. It's not appropriate. So the most the NRC is willing to accept is just a caution or a note or some sort of a reference in the procedure that says consider using 5054X for this procedure, or something to that effect. But don't tie the operator's hands to using 5054X. The implementation of that the implementation of 5054X has to be at the operator's discretion. You can't tie their hands and drive them into a 5054X declaration. Next one is ensuring phase rotation checks. It's again a simple, obvious one. You know, your 480 volt or other flex equipment that has 3 phases. You want to make sure when you repower it that the phases or the pump or whatever equipment you have is going to rotate the right direction. So you got to make you want to make sure that that's controlled somehow. Next one is storage temperature checks. If you have a maximum allowable temperature of your flex storage building, then you should be checking it periodically and recording it. You should have an action to do something if it exceeds a certain value. And same thing on the lower side too, if you have a minimum temperature. If you don't have a maximum temperature, if the maximum temperature is 150 or 200 degrees and it'll never get there, just be careful of if you're doing if you're going out in the field and checking temperature, just make sure that the person measuring the temperature knows what to do if the temperature does get above a certain value. And if it's something very high, consider whether or not you need to be doing those temperature checks. If it's 120 degrees in your flex storage building, and after that you need to open a door, well, then you should be giving that to your operator and saying, well, if you're out there and you measure at this degree, this temperature, then go do this. But have a step for the operator so that if he's out there and he does measure it and it's 150 degrees in your flex storage building, he knows what he knows what to do, not just record the temperature. Next one is operational versus design margin. This is always a touchy point with engineering and operators. To give you an idea what this means, design margin or engineering margin is the margin that an engineer puts in the design. So steam generator makeup flow is a good example. So let's say I do an analysis, and that analysis says that the 200 GPM of makeup flow to the steam generator is a good number, and I have some margin. I use some assumptions that are conservative. Really, the number might be down as low as 185 or 190. That would really be the analytical minimum to cool a core. So, but I'm going to say it's 200 because there's a little bit of margin there, and I don't want to eat into my design margin. So then the engineer puts that, tells the operator, well, I have this, 200 GPM is the engineering limit, and operationally though, we're not going to operate at the engineering limit. That's kind of crazy. So we're going to operate at a value greater than that. So you might go 10% more or something, or 5% more. So maybe you do 210 GPM, and that's what goes in your procedure is 210 GPM or something to that effect. So that's operational and design margin. That's where you actually will operate it versus where it was the design says you can go. And there's different ways to break that out, and whether or not it's in the procedure or where it's the operator generally operates it. But that's the basic idea. So one is kept with engineering, and the other is kept with operations. So one site had an issue, and it wasn't really a big issue with this margin. They had a step that was driving them into a 30-minute operator action following an ELAP. I think it was about 30 minutes. To get power to the batteries, because the design analysis, the results of that, there was a lot of margin in it, but it said, if you get power back in 30 minutes, it'll be acceptable. It didn't say anything much beyond that. Realistically, looking at the analysis, though, you could get hours, so 6 to 12 hours out of the batteries before you needed to get going and get power hooked up to them. So keep that in mind. The engineers could have tweaked the analysis and given it to operations, so operations would have had more time to get this implemented. It didn't turn into a big issue because it was doable, it was possible, but it's something to keep in mind. The next one was missing tools and mislabeled components. Again, this goes to the quality issues like the FSG quality. Just make sure that your strategies are all buttoned up, and when they go out in the field, things look right. You don't want you don't even want different labels on different equipment. You want all the labels to be similar across all the equipment, and that helps with human factors too. When an operator goes out in the field, you want to know that this is what flex equipment looks like. Does it have a specific, a special identifier on it that says this is flex equipment? I know some sites did some glow-in-the-dark things or some reflective things, but make sure it's consistent. It goes to quality, and if it's not consistent, it's not well labeled. It's just fodder for the NRC to dig a little deeper. So pause for any questions. Okay. About 20 minutes into the presentation, so we're going to continue on. So now we're going to talk about regional trends. This data was not presented at the conference. This is some information that we put together ourselves, helping us with our audits when we go to sites and do their inspections and do their audits. So, as I said earlier, we're up to about 17, but not 17 sites that have been inspected, but not all of those sites have data yet. We compiled all of this from the inspection report, and we took the inspection reports and took a lot of the data out of those and compiled them. So we have 11 of the sites had reasonable data to use. Some of the sites had inspection reports, but the data wasn't strong enough for us to use, and we didn't want to skew our results. I just lost my screen. There we go. So these are the sites that we were able to base this data on. You can see the list there, 3 in Region 1, 4 in 2, 3 in Region 3, and Palo Verde is the only site in Region 4 that we had good data for. So just keep that in mind. You can't really draw a trend off of one site, but we presented the information anyways. So here we go. Here's the first look. So when the NRC comes to your site, what are they going to look at? Mostly procedures, which makes sense. So they're going to look at your FSGs, EOPs, alarm response procedures, things like that, things that the operator is going to be using during the event, because really it helps the NRC know what's going to happen, what's the operator going to do. So that makes sense, and it averages right in the neighborhood of 50 or so. For most areas, with the exception of Region 2, as low as about 30 on average. This is an average. The next one is issues reviewed. We call this issues reviewed. It's condition reports, issue reports, action reports. Everybody has a different term for it, but the NRC will come in and their inspection manual tells them to look at issues, CRs that were written on Flex. So this gives you an idea of how many CRs they're going to look at. And again, this is region by region. And I should mention too, the reason we broke this out region by region is because they're different inspectors. Each region has their own lead inspector, and there's a cross-regional panel to compare findings or issues and to make sure they're binned consistently from region to region. So binning of issues is consistent across all 4 regions, but identification of issues isn't necessarily consistent because you have 4 different lead inspectors identifying issues as they see them. So you can't really get a true consistency, but the NRC does work pretty well to get there. So as you can see, that's the top 2 things that they'll look at are procedures and CRs or issues. And again, other things they'll pull out are work orders, training documentation, drawings, calculations, mods, things of that nature. So this chart here is comparing findings and issues that were found. So findings are truly green findings. So those are the 3 green findings. Oh, I got to fix this chart. Findings and issues. So if you'll take a look, this chart's incorrect, but on the right-hand side, you'll see that's the number of findings the NRC has found. So they've only found 3, but they were all in Region 3. and you can see the number of documents reviewed for each site and the number of issues that were found. Now, the number of issues is the number of condition reports or issue reports that were generated as a result of the inspection. So that gives you an idea of, if there are some lower level issues that didn't quite creep up to a finding, but they were still documented in cap space. Now, a caveat here is every site is different in terms of their threshold to writing an issue report. So this isn't necessarily a strong identification of a trend by region. Some sites issue condition reports for things that other sites would consider to be very minor. So just keep that in mind when you're looking at this. Okay. So here's a roll-up of all the issues, sort of a summary here. So most of the lower level issues, again, these aren't really findings, these are issues. So things that went into cap space but did not boil up to the level of a finding. Most of them were with documentation, 61%. 16% were miscellaneous field issues, 10% due to labeling errors, and 13% PM issues. The labeling error one is interesting. I want to talk about that for a minute. Another thing that the NRC found when they were inspecting their sites is the procedure didn't necessarily have the exact same label as what was in the field, and that can be a big deal. It sounds like it's a minor issue, but you want to make sure that if your procedure says breaker BREAKER 21 and your field tag says BKR 21, you want to get that resolved because the NRC is going to ask, how do you know BKR 21 is the same as breaker 21? And really, it can get it's a tough spot to be in. You don't want to be there, so just make sure it's consistent. It should be. So any questions on the issues that were identified? Moving on. So now we're going to talk about best practices. We're about 30 minutes into the presentation. So on day one, the NRC would like to see you present your strategies. Again, these best practices were presented by a combination of the NRC and panelists. And I'll send out the link to these presentations after this webinar is over. So on day one, give a presentation as soon as the NRC gets there. They get in, they get settled. Give them a presentation on your strategies and what you do and what things look like. For speaking for somebody that has been doing audits, it helps to have visuals. All the sites are laid out differently. There's different terms for different buildings or different systems, and it's not consistent. So it's just make sure that you have visuals. Describe what buildings are. Remember, you're trying to teach somebody about your strategies that may not have ever been to your site before, or at least isn't very familiar with your site. They should be somewhat familiar with your flex strategies, but they're not going to be very familiar with your site. Timelines are also another big help. That was mentioned at Watts Bar for their inspections. It depends on your strategy, but if you have a lot of things that stack up and some time critical, or time sensitive, we'll call it, time sensitive actions, just make sure that those are done, that those are, timelines help to explain that a little bit better. And you can show it visually on a Gantt chart, and it'll help a lot. The simulators can be used, but it's not necessary. There wasn't really much of a lean that I could tell from the NRC that was a better thing to use a simulator. It's 6 of one, half a dozen of the other. But if you feel that it would give the NRC some more insight, then certainly go ahead and do it. The next one is multi-source dose assessment. The NRC actually really liked being able to see somebody do it, an actual computer demonstration of the dose assessment and how that works. It does help a lot because when you're talking about reading a procedure on dose assessments, one thing, but to actually see it done, because every site has different software and different ways that they're going to do it. So it helps to see it actually done. And the next is FSGs and procedures. So when they get there, it's best if you can have those procedures printed out or otherwise available to them so that they can get them quickly and pull it up and read them and understand what you're doing. And certainly make sure that it's the current revision. Next is so more of these best practices. So the support team. Mike Powell from Palo Verde had a great example of a best practice. He moved the support team supporting the inspection close to the NRC, which a lot of people do, but he also gave them computers. And when the NRC wasn't, they weren't busy answering NRC questions, they could be on the computer doing their work. Not only does that help increase the organizational efficiency, but it cuts the stress down on the engineers and operators because it allows them to work on their things so they don't have a bow wave of work when they get back. I know I've sat in rooms before and you just sit there and think about all that work that's waiting for you when you get back and how you're going to do it, and you're going to have to stay late and all this, and this really helps to cut the stress down. So, and to that end, make sure you get IT involved early to help them have them set up computers if you can. The next one is using your knowledge base appropriately. So the NRC will ask the same question to a number of people to gauge alignment and to find out if people understand what's going on and if you're going to get the same answer from every operator, and they should. So to that end, make sure that all of your flex knowledge isn't maintained in one person or one operator. Certainly you do want your knowledge base to be there during the inspection, but your training program should have trained the operators and other personnel well enough that the NRC should be able to basically walk down the cubicles and ask any person, and they should be able to explain what their duty is for flex. They don't have to explain everybody's duty, but they have to know what they're responsible to do. Now that said, they're not going to do that. They're not going to walk down the aisles and start asking random people. But that's just a good way to explain that. Make sure everybody's aware and everybody's on the same page, and they know what to do. And it wouldn't even be a bad idea to do a station update or something of that effect of a quick refresher on flex for each department on what they're supposed to do. What that department's or what that role is for those people. So more best practice, ops ownership. This is something from the early inspections that was really picked up on. Was the NRC wants to see operations own this stuff, and they want to see that it transitioned through projects to the site, because that handoff is very important. And we know that when a lot of times when things get handed off, things can get dropped or misunderstood or not fully transferred. So ops owning it and really leading the strategy and owning the strategy and knowing what has to get done is very important. And the NRC recognizes that. And the next one is, again, all operators should be knowledgeable. You don't have to have your auxiliary operator or your equipment operator knowledgeable of every EOP, because they shouldn't be. It's not in their realm of responsibility. But they should know what they have to do to implement. And to this too, with training, make sure that your operators are trained on alternate power for spent fuel pool. It's an explicit requirement, actually, right out of the TI that says that they have to be trained to get alternate power to the spent fuel pool level indicators. So depending on your setup and what it looks like, just make sure they're trained, or they have otherwise somebody knows how to get alternate power to the spent fuel pool level instrumentation, and that they know and that will happen, and that they were trained on that. That's important. It's one thing that can get missed because everybody focuses on flex, and the other things can get dropped. So it's an explicit requirement. Just make sure you do it. So pause for questions. We're at 36 minutes. And now we're going to move into the compliance matrix. So this is The method that we use for self-assessment, I'm going to explain it here, and then obviously I'm going to try to explain it to the level that you could take it and just implement it at your site. If you do want help with it, or you want us to do it for you, we'd be happy to do it. But again, the purpose here is just to explain our process, and you may be able to adapt it to your site or use it how you see fit. So first, a little bit about what sites are doing for their self-assessments. Some sites have mentioned that they use the TI, and that's as far as some sites are going. They break it down into requirements. We've done this, and we came up with about 74 requirements, and they document compliance for each requirement, how they met each one. And this is a good approach. It's reasonable. It's a manageable list of requirements, and it's broad, and it covers everything that the NRC is going to look at from a high level. So this is a good flyby type of assessment. It's a quick way to make sure everybody's in the right spot and that they're doing the right things. And again, so it's a good approach. The cons of this, the way we measure the requirements, and I should mention that I use the term requirements is used loosely here. It's not an explicit NRC requirement in regulatory speak. These are requirements that are maybe out of an NEI guideline that the NRC is expecting you to do, that you don't have to do, but that's what we consider a requirement, though. It's if you didn't comply with what we call a requirement, it could cause you some pain or a hard spot. So I should cover that first. But that's what we consider requirements. So, but the TI accounts for less than 10% of all of the requirements. So you say, okay, well, we need, where else are the requirements hiding? Well, some sites have done NEI 1206 for their self-assessments, and with that, they break that document to whatever rev they're working to down into the requirements, and there's about 499. It depends on which rev you're working to and how you measure it. And then they document compliance for each one. Again, the pros for this is now it's a lot more detail on Flex. It really covers a lot on Flex stuff. So you'd probably be in a pretty good situation for the Flex portion of the inspection, but the cons are that it misses dose assessment, it misses spent fuel pool level instrumentation, and it misses communications. Those three things aren't really mentioned much at all, if at all, in 1206. And certainly if that's all you did, you would be missing a few things on your self-assessment. So self-assessment. So where are all these requirements coming from? I mentioned that the TI only had less than 10% of the requirements. Well, these are all the documents that the NRC has endorsed and said that this is a reasonable way to do Flex. So the orders, obviously, that came right from the NRC, as well as the inspection manual. You have to meet those orders. At the end of the day, that's the name of the game here. And the inspection manual is making sure that you met the orders. But we also have guidance documents. We have 1206, 1201, 1202, and we have the ISGs that endorse the guidance documents. And there's more here. There's more than what's on this list. But this gives you an idea of what the requirements are and where they are. So where are they? So there's 862, how we count them, requirements. And so again, you can see a breakdown here of what they look like and where they are in each document. And notice even the ISGs have requirements. The ISGs have adopted the guidance documents like 1206, but sometimes it'll say that, for example, the wind map. One of the ISGs said, we endorse 1206, but we don't endorse that wind map for your wind speed. Right, so that's a requirement. Don't follow that wind speed. It's sort of a don't requirement. Don't use the wind speed in 1206 to design your Flex strategies. Just use that as a screening criteria to figure out if you need to design for wind. That's all it is. So that's an example, but there's others as well that you have to keep in mind. So how do you know if you're in compliance with all 862 requirements? So we have a compliance matrix process. So it's a 6-step process, and the first 3 steps we've already completed. So you collect and analyze the documents, you extract information, organize them into categories, review the site documents, and document how you comply for each requirement, and then you generate a report. So the first step, step 1, is collecting and analyzing. So these are some example documents that we'll collect and analyze. So we're 41 minutes in. And we'll take a look at. So we got the orders, the NEI documents, and more. So next is the interesting part. This is the part where we it's a little bit of judgment, but we make sure that we get every requirement that came out of these documents. So the way we do that, I'm going to go to the next step here, is we basically used Microsoft Word, and we highlighted each requirement and gave it a number. So here's an example from section 3.2.1.3 of Rev 0. It's an older one, but you can see here that we have installed electrical distribution systems, including inverters and battery chargers, remain available provided they are protected consistent with current station design. That's a requirement. So if you're going to credit your electrical distribution system, like inverters, battery chargers, things like that, it has to be protected. It's an obvious one, but it's a requirement. And so that one gets ID number 124. Okay, so it's traceable. So, and I'll show you where we use that next. So, well, next is requirement categorization. So the different requirements go into different places. So some of them are related to maybe spent fuel pool level instrumentation. Some of them may be related to the critical functions like core cooling or containment cooling, etc. So that's the idea. We break them down so that you can search them later and find all the requirements related to core cooling, or find all the requirements related to high wind hazards is another category. Okay, and these are the categories that they're broken into. So you can see boundary conditions are just all rods are inserted. You don't have to assume one rod is out, things like that, and the rest are fairly self-explanatory. Okay. Sorry, we're going to move a little bit quicker here. We're about 43 minutes into the presentation here, and I'd like to give you a demonstration at the end here. So the next is the site documentation review. Documents are reviewed include but are not limited to the following. So this is basically everything. The NRC looks at, on average, I think it's between 50 and 70 documents when they come to your site, depending on region. We look at between 200 to 300 when we're doing our audit, because we want to make sure we get everything. So the FSAR is big for information. FSGs are the most common one, and EOPs, and how do you get into the FSGs and transition in and out. We take a hard look at calculations too. And another reason that we do this is the NRC has already looked at a lot of your calculations when they did the audit. But when we're doing an audit for a site, we haven't looked at your calculations. So we're going to, even if the NRC has already checked your calcs, we're still going to come in on the backside and double check. And we do that just to make sure, you have a different inspector, a different set of eyes. You just want to make sure everything's buttoned up and ready, so that when they come to your site, they won't find any issues. So the next is the compliance determination. This is a long process. This is for each of those over 800 requirements. We're going to go through and document how you comply. And each requirement has different attributes to it. So you may have a hazard requirement, and it may say your equipment has to be protected from extreme hazards or something. So okay, well that means flooding, seismic flood, wind, and high temperature, high and low temperature. So we would document for each of those attributes how the hazards are complied with. How do you protect? So that's just an example, but it's the same thing for phases and other categories. Okay. So next is the compliance documentation. So that's the determination. Then this is the documentation. So after everything is after we figure out that you comply, we document it. We put it in the database, and so it's easily searchable. You can easily update it. We cross-link to reference documents. We can cross-link to flex equipment, assumptions, open items, anything like that. We can cross-link everything so that you can easily search and find out the related issues, related things. Excuse me. And when we're finished, we generate a report. The report's quite large. It's normally about 1,000 pages long because about several hundred of those pages, anyways, is the guidance documents and how we extract it. I'll go back a few slides here. This, when you attach each guidance document, NEI 1206, a couple hundred pages long in and of itself. Then you put in 1201, 1202, the orders. It adds up. So all that's in there, so you can easily find what you need. And so that's basically it. So the benefits of using this during the inspection, we've audited 2 sites that have gone through an inspection, Millstone and North Anna, and it increased their response time quite a bit. They were pretty happy with it. The feedback that we got was the searchability was nice, and the biggest thing was being able to find the document. That it was the person doing it said, yeah, I think we have a document on that, but I don't remember where it is. So all they have to do is pull up the database and search. Maybe it's tornado, a document that has something to do with tornado or separation or something. So they just search their keywords, and they'll find how they comply with the requirement, but they also find the reference, that reference that points to that. And then they can pull that, and they can give that reference document to the NRC. So that was some feedback that we got that was part of the most helpful. It also gets the team up to speed pretty quickly. If you have this, they can search through it pretty quick and say, oh yeah, that's how we do it, and oh yeah, that's how we comply it, and yes, this is why it's okay, and especially if you have something where it's a little touchy, maybe you needed to get special approval from the NRC for something, that would be documented in here. So before we move on to open discussion, I'd like to show a quick demonstration here of the compliance matrix. So you should see this on your screen. Yep. And this is a generic one. So this one's not filled in, but this is what it would look like. This is what our product looks like, and you can again. So documenting compliance, you just click up here, go to compliance. I'm not going to go through all this right now. We're kind of running low on time, but you can just go through here. You can filter here and find what you want to document compliance for. Click your compliance input button. Wait a minute. So here's your requirement. This is just one requirement that we found. And then how do you comply with that requirement? Okay, and then you can scroll through and find how you comply with all these. So again, this isn't filled in yet, and here's your references, and this would obviously be all filled in. Categories for flex, spent fuel pool communications, how it complies. So you get the idea there. You can input equipment information here, all sorts of equipment information, references, and here's the big thing that helps during the inspection is search. So just doing a simple text search. So I can search tornado, and I can hit search, and I come up with 10 things related to the word tornado, 10 requirements. And those just have the word tornado. If I can also search something like wind, and there's 17 requirements that talk about wind. So that's again just an example, and this is just a generic, just for the purposes of this presentation. But there's other ways to search here. This is we try to make this similar to Google, but it's tough. So we have you can search by category, you can search by section, by different. Say the inspector says, how do you comply with NEI 1206, section 7.3.1. Charlie? You can just type that in here, search it, and you'll find it. Also, issues. When we finish, we will find issues for your site. Generally, it's in the neighborhood of 50. We'll find 50 things that you could do to improve your site. Those issues we split up into gaps, AFIs, and enhancements. And the way we use it is gap is an issue where you have a gap. You do not meet something in NEI 1206 or one of the guidance documents, and you just need to be very careful. Doesn't mean it's going to be a finding. It could be a finding, but it's the highest level issue that we identify. And there's generally a neighborhood of 5 to 10 of those. then AFIs are basically mean that you may not be able to implement your strategy, depending on certain scenarios and what could happen. So it's lower level, and the next one is enhancements. So enhancements are those issues that are not really issues. It's just we recommend buttoning something up and to enhance your strategy. So, and right here is where you'd be able to search those issues, and you can find the requirement. So when we say you have an issue with, I don't know, timing of batteries or something like that, you'd click that issue, hit search, and it would find the requirements that say that you have to get batteries repowered. And reference to requirement search, this one is all of your references. So let's say you have a document on separation. It's a white paper that you put together on tornado missile separation. Well, what requirements are related to that? So you might want to know if you're going to update that document, you might want to know what requirements am I touching? What requirements am I affecting? If I change this, what do I need to be thinking about? So that's useful there. So you would just highlight your reference, hit search, and we'll find all the requirements that are linked to that. So it's a useful tool for that. So again, so that's the end of the presentation. So some of the topics we covered are shown here. Let's see. Go to the end. So some of the topics we covered a little bit about us, industry inspections, NRC findings, regional trends, and the like there. So time for open discussion.